All right, we discussed a lot. Let's actually hit the flag and see the effects of our work. So I'm going to play a little bit until I have a score equals 10. So we have two sprites there, but they still didn't change the way I wanted. So I'm going to go to score and I'm going to simulate the increase of score. So I'm going to first show the sprite and I'm going to clear the graphic effects so that the score sprite is here at the dead center of the screen and the score is 0. So if I change the score here to 9 and then move to 10, we have two scores with the costume 0. And if I increase the score, still the wrong sprite increases its costume, which is wrong. But fortunately, this time it's very easy to fix because every single clone, including the original sprite, has its own value for that digit position variable we worked so hard to program. So here in the when I receive score point script, instead of switching costume to score plus 1, we are going to remove this and we're going to go to operator. And I'm going to bring this letter of block. So I'm going to bring in the letter of the value digit position of this clone of the score. So I'm going to go to variables and I'm going to say letter with the number digit position of the score. This basically assigns every letter of score to every score sprite on the stage. The original sprite has digit position equals 1. So the letter 1 of score means the first digit of the actual score variable. Alright. The first clone has digit position equals 2. So the letter 2 of score will be the digit appropriate to the first clone. And so on and so forth. Every clone will have its own digit position, and thus it will have its own letter of score associated to it, and thus it will have its own costume associated to it. So let me show you. If I set the score back to 0 and if I click this block, so I increase the score to 1, and if I get to 10, notice that the first original clone already increased its costume to 1. And if I increase the score again, notice that we have a sudden change. Well, that is because there's something else that we haven't fixed, which is the creation of clones. If I drag this around, we have so many clones sitting around. That's because if the score is bigger than 9, the original sprite creates a clone of itself. And not only that, but the existing clone creates another clone of itself. And every clone creates another clone of itself. So we have a huge amount of clones on the screen. So we need to fix that. First of all, the condition under which we create a clone is not valid anymore. We don't just create a clone when score is bigger than 9. We create a clone when the length of the score has increased. So I'm going to bring this out. And I'm going to add a smarter way of changing whether the length of the score has increased. Watch what I'm doing. So I'm going to go to operators and I'm going to bring this length block and I'm going to bring it twice. And in the first block, I'm going to bring in the length of score. And here, I'm going to bring in another operators block. And I'm going to bring in this difference block. And in the first space, I'm going to bring in score. And in the second space, I'm going to tell 1. Let me move these blocks a little bit and let me explain what I'm doing. So this condition says, length of score is bigger than length of score minus 1. Well, what does that say? If the length of score is bigger than the length of score minus 1, then that means the score has increased its number of digits. Think about it. If you have score equals 10, the length of score is 2, but the length of score minus 1 is the length of 9, which is a single digit. So the length of score is 2 digits. The length of score minus 1 is 1 digit. So if the length of the score is bigger than the length of score minus 1, then the score variable has increased its number of digits. That also happens when you move from score 99 to 100. The length of 100 is 3, the length of 99 is 2. So this is the condition that tells whether score has increased the number of its digits. So keep that in mind for future reference when you want to display some scores on the stage. All right. Now, I'm going to not only create a clone of myself, which creates a clone of every single score sprite that happens to be on the stage, but I'm only going to create a clone of the original sprite. All right. So I'm going to restrict that by adding another if block inside. So I'm going to create a clone of the original sprite, but how do we tell all the clones from the original sprite? Well, every single clone and the original sprite has its own value for this digit position. So we can use that as a separation. So I'm going to bring in, from the operators block, I'm going to bring in the equal sign, and I'm going to go to variables, and I'm going to bring in this digit position, and I'm going to enforce digit position to be 1, because digit position is only 1 for the original sprite, because that's how we set it to be at the new game phase. So let me hit the flag now and clear all these clones from the stage. And I'm going to stop the game, and I'm going to go to looks, and I'm going to click on the show so that we bring the original sprite on the stage. The score is equal to 0, and I'm going to trigger the broadcast of the score point message so that we validate that the scores are computed correctly. So we have score equals 3, 4, 5, 6, 7, 8, 9, 10, 11. So notice that only the clone changes its costume. The original sprite doesn't. 19. Now both of the sprites should change their costume, both the original sprite and the clone. Good. So we have both the original sprite changing to 2 and the second sprite, the clone, changing back to 0. And so on to 30. If I set score to, say, 95 and click this thing again, we have 96, 97, 98, 99, and at this point we should see the triggering of and the creation of a new clone. So we have 100 here. And if I increase the score again, notice that every single sprite, every single clone, including the original sprite, knows whether to increase their costume or not, based on these formulas that are very hard, but they do their trick. And at this point, we are ready to fully play the game. So I'm going to go to variables, and I'm going to uncheck the digit position and the score, and we're ready to have our own game. So now the scoring sprite works correctly, but I've sadly crashed my Flappy, so let me play again. Fortunately, our game runs indefinitely, so we have scoring. Good. Alright, so we have a fully playable game now. Now there are some small cosmetic things and small improvements that we can make to this game. For example, notice that when Flappy crashes into one of these obstacles, it goes slightly through the obstacles, which is something that I'm not particularly fond of. So let me change that a little bit and make Flappy crash into the obstacle and move slightly to the left so that we get the impression that Flappy is actually colliding with the obstacle. Fortunately, that's pretty easy. We have this little script which waits until you're colliding with the ground or with the pipe, and we have Flappy changing its ghost effect by 20. We can also, in the same loop, change Flappy's X position by a small amount. So I'm going to go to motion, and I'm going to change X by -3, which is the speed at which the ground moves and the speed at which the pipe moves. So if I click the flag again and I start the game again, notice the difference. It's very subtle, but it's easy to see. Now, the second thing that I would like to change is to make this game slightly parameterizable and to allow you to make the game potentially more difficult for whoever's playing. So, for example, notice that both Flappy and the ground and the pipe move to the left by this -3 amount, which is the same for all the sprites. Let's parameterize that by creating a variable. So let's create a variable for all the sprites, and I'm going to name the speed. All right. so that when the flag is clicked, we set this speed to 3. All right, so set speed to 3. And when Flappy changes x by -3, we will change x by 0 minus speed instead. And I'm going to explain the benefit in a second. So change x by 0 minus speed. I'm also going to uncheck the box so that speed doesn't need to be visible on the screen. Let's check for other places where we change the x coordinate, but in the case of Flappy, we don't have. But for the ground sprite, we change x by -3 all the time. So let's create that again. So 0 minus speed. And I'm going to snap that here where we move the ground. And I'm going to right click and duplicate it and put it in the other couple of places as well. And the same for the pipe. So I'm going to bring in the operators, difference, 0 minus speed, and I'm going to snap it here, duplicate it and snap it here as well. And there's another place. I'm going to duplicate it, and I'm going to snap it inside though when I start as a clone block. All right. So that when I click the flag now, nothing has actually changed because the ground and the pipes move by the same amount. All right. But now the benefit is that if I change the speed from 3 to 10, for example, all of the elements of the game are suddenly going to move faster, so that I don't need to change that amount everywhere in the program. So if I change the speed to, say, 7, and if I hit the flag, notice that everything starts moving a lot faster. But the pipes are also pretty distant from one another, so we can change that. So the waiting time will be shorter the bigger speed is. So instead of 2, I'm going to bring in this division operator. And I'm going to say 6 divided by speed. So that when the speed was 3, 6 divided by 3 was this 2 seconds that we're already waiting. But if speed gets bigger, for example, if speed gets to 6, then we'll need to shorten the waiting time. So I'm going to snap it here. So notice the difference now. The speed is equal to 7 or 10. What did we put? We put 7. So the pipe now waits 6 divided by speed, 6 divided by 7 seconds, so that's even less than a second. So the game is much more difficult now. See? It's also much more of a challenge, and I also think it's a little bit more fun. So we have this little parameter here that will dictate how fast the game is going to move. The second parameter that will dictate the difficulty of the game is gravity, which we already have. But if I increase gravity to, say, 3, this will make the game quite more challenging. See? But if I also increase the jump by which Flappy soars into the air, that will also add to some spiciness of the game. So here, notice that we're setting the vertical speed to 7. We can customize that by creating a variable. Let's name this jump. And the jump variable will dictate the amount by which Flappy will soar into the air. So I'm going to check this box to make it invisible from the stage. And I'm going to set it, so set jump to 7. And when Flappy jumps, I'm going to set vertical speed to the value of jump instead of 7. So now this allows me to customize how far can Flappy fly into the air when I press the mouse button or the space bar. So if I increase this jump from 7 to, say, 15 and I increase gravity to 4, the game will be almost impossible to play. So see, if you want to make this game very difficult for your players, you can customize these values, right? If you want to make this easy, set the speed to 3, set gravity to 1, and set jump back to 7. And if you're coming from an impossible game, this will be a breeze. You can score points all day. But I'm just gonna crash and let you guys have all the fun, because we are done with Flappy Bird. I am really proud of you. This was a hard game. So take a step back and enjoy what you've done and what you've learned, because you've done a lot. We've learned about gravity and some hard math, and we've done some complex programming in this game. You're now ready to code almost any game that you want. But I have just the challenge for you, starting in the next chapter.